Hi, my name is Rehab Alahmadi, and I will present our work, Improve Image Captioning by Estimating the Gazing Patterns from the Caption. Image captioning is the process of automatically generating a human-like natural language description of an image. For example, given an image, we want a model to generate a description that describes objects in the image and their interaction. Modeling image captioning is highly inspired by human cognition, mainly image perception that understand image contents, and sentence planning and generation to describe the image with a natural language. In this paper, we focus on improving the image perception part of the current image captioning models. To generate an image caption, current state-of-the-art models heavily depend on CNN and RCNN to extract the visual features. These methods can generate a human-like description by learning visual feature purely from the image. Such methodology does not explicitly account for how a human perceives the image in order to describe it. Therefore, different studies showed that incorporating gazing pattern learned from eye tracking system to image captioning models can improve image captioning. However, eye tracking system is expensive and not accessible. To capture better visual features for image captioning, we need to understand the human's perception and cognition when they generate descriptions. Previous studies showed that there is an agreement between word ordering and eye movements, such as the order of gazing the object is correlated with the order of mentioning this object in the sentence. Based on this finding, we hypothesize that the entity ordered in the description reflects the human perception of an image when a human initially generated the caption. Therefore, we estimate gazing pattern from entities mentioned in the caption directly rather than using expensive eye tracking system. Then, we incorporate this gazing sequence to image perception part of image captioning models to investigate its performance when gazing sequence is used as a visual feature. Here's an overview of the model architecture. Our model consists of two parts. The first part is gazing pattern prediction network, which learn to produce gazing sequence of an image. The second part is integration of the gazing pattern to the image captioning models. Let's take a look at the gazing pattern prediction part. For this purpose, we utilize the pointer network to model gazing pattern prediction. First, we extract all the regions from the image using RCNN. Then the encoder by LSTM learns features from a sequence of regions in an arbitrary order and encodes it into a hidden state that is used to initialize the decoder. The decoder is an LSTM which learns to point to the regions in order and generate the gazing sequence. In the first time step, the input is the feature of the image, so the model can have a contextual information before pointing to the first region. To incorporate the gazing pattern into image captioning models, we propose a model-agnostic gazing pattern subnetwork that can be plugged as an additional visual feature to image captioning models. We utilize LSTM, we call it a visual LSTM, that takes the sequence of the gaze region as an input and encodes it into a fixed size hidden vector. The visual LSTM is optimized with image captioning models such that the LSTM in the language model is initialized with the learned gazing pattern. We integrate the gazing pattern subnetwork to three baseline image captioning models, namely NIC, Adaptive Attention, and Attention on Attention. This table shows the result of the investigated image captioning models with and without the additional gazed features. All image caption models benefit from the gazing pattern subnetwork to some extent. Some models improve significantly than the other. We compare the performance of the attention on attention with the gazing sequence with the state-of-the-art models. We report the result for two optimization, cross-entropy loss, and CIDEr optimization. Comparing our method with XLAN, our method achieved comparable performance with XLAN when both models trained with a cross-entropy. However, the performance of our method was slightly better in most metrics when optimized by the CIDEr score. Here is the result of our qualitative analysis. Although attention can generate caption relevant to the image, adding gazing patterns can produce more accurate descriptions. In conclusion, we present a gazing subnetwork that models the human perceptions as additional visual features to the image captioning models. We adopt the pointer network that automatically produces a gazing sequence. Our experiments show that adding gazing pattern as an additional features to the encoder has enhanced the performance of image captioning models.